Welcome to this explainer. Look, right now, across the globe, companies are absolutely racing to integrate AI into every single facet of their business. It's thrilling, it's transformative, and honestly, behind the scenes, it is setting fire to cloud budgets at a completely unprecedented rate. We're facing this really high-stakes reality where everyone wants the power of AI, but very few are actually looking at the meter while it runs. So today, we're going to unpack how to master cloud cost governance for AI workloads so your innovation doesn't end up bankrupting your infrastructure. Because there's a huge trap so many teams are falling into right now. If your organization is running AI workloads without a cost governance model built for them, you are already overspending. You just haven't seen the invoice yet. It's kind of a chilling thought, right? That invisible invoice is racking up in the background at this very second. The meter is spinning, and by the time the finance team actually gets the bill, the damage is completely done.
Okay, let's dive into this. Here is our roadmap for getting out of this expensive mess. 1. The hidden AI invoice. 2. Why AI breaks standard rules. 3. The real AI cost drivers. 4. Rebuilding FinOps for AI. And finally, 5. Engineering the solution.
So, starting with part 1, the hidden AI invoice and the AI cost crisis. For years now, traditional cloud billing has actually become, well, pretty manageable. Sure, you get some fluctuations here and there, but overall, it's steady. AI spend is an entirely different beast. It's an impending disaster if you leave it unchecked. To fix this, we need a highly specialized discipline, FinOps for AI. This is the practice of applying financial accountability, forecasting, and strict cost governance specifically to AI workloads. We aren't just talking about regular web servers anymore. We're dealing with massive GPU compute, heavy model training runs, continuous inference, and really complex data pipelines. It has to be a distinct, specialized discipline because the hardware and the behavior of these workloads are entirely different from traditional cloud operations.
Which brings us to Section 2. Why AI breaks standard rules. We've officially reached the end of predictability.
And this brilliantly illustrates exactly why. Think about standard cloud as a safe, predictable commute. Storage grows in a linear, plannable way. You can forecast next quarter's bill with a totally reasonable margin of error. AI workloads, on the other hand, are a roller coaster. GPU pricing is highly volatile, and the hardware itself is incredibly scarce. Training costs spike unpredictably. A single large model run can easily consume an entire team's monthly budget over a single weekend. Inference costs scale exponentially with user adoption, meaning your success literally makes the bill go up. And perhaps the worst offender? Expensive idle waste. Having reserved GPUs just sitting around unused for staging will burn through your budget incredibly fast.
All right, Section 3, the real AI cost drivers. Let's take a look at where the budget actually bleeds.
You're probably already tracking these standard cost drivers, right? Things like training compute on high-end GPU clusters, inference compute scaling with user adoption, and the heavy data pipelines and storage required to clean and move massive datasets. But tracking just those three? That's only part of the story. You are missing the absolute biggest leak in the boat.
Experimentation overhead. This is the monster hiding under the bed. It's the cost of failed experiments, abandoned model versions, and duplicate training runs that never even make it to production. A single rogue script left running over a long weekend can silently burn $10,000 before anyone even notices. Yet most companies just write this off casually as the cost of doing research, rather than treating it as a governable line item. And because it flies under the radar, it so often becomes the largest, most dangerous hidden cost in your entire AI operation. Moving on to Section 4, Rebuilding FinOps for AI. It is time for a new paradigm. So, the crucial point is that traditional FinOps rules have to be rewritten entirely. You can't just have engineering and finance in the room anymore. Data scientists absolutely must join them because they control the biggest cost levers, your model architecture and training frequency. We also need strict ownership. Compute isn't just a research toy anymore. Every single training run and endpoint needs a named owner. Your central teams have to develop deep technical fluency in GPU pricing and spot strategies. And vitally, visibility must be near real-time. Standard weekly reports are not going to cut it when a misconfigured training job can burn tens of thousands of dollars in a matter of hours. Ultimately, your decisions have to be driven by business value. Spending $50,000 to improve model accuracy by 15%, that might be a fantastic investment. But spending that exact same $50,000 for a tiny 0.3% improvement, that is just wasted capital.
Which brings up one of my absolute favorite analogies from the source material. A dashboard that shows you last month's total AI spend is not FinOps. It's a rearview mirror. Really think about that for a second. Traditional cloud cost platforms give you visibility, sure, but visibility alone doesn't solve the problem if it's delayed. Catching an AI cost overrun after the invoice arrives is quite literally like watching a car crash in your rearview mirror. It's already happened. Real FinOps for AI catches the overrun while the training job is still running. So let's turn this into an actionable framework. If you want to stop the bleeding today, here are 5 steps you can take. 1. Set budget guardrails at the experiment level. Every single run needs a pre-approved ceiling. 2. Separate your research spend from your production spend in your reporting. Research can be a little inefficient, but your production inference absolutely must be optimized. 3. Use spot and reserved instances strategically. Training jobs that can be interrupted should definitely run on cheaper spot pricing. 4. Automate shutdown policies for idle GPUs. Do not rely on humans to remember to turn off the lights. Automate it, and you eliminate massive waste instantly. And 5. Review cost for outcome. Always track your spend against the actual model performance improvements.
Finally, Section 5, Engineering the Final Solution, Moving Beyond the Dashboard.
Because tooling alone is not enough to solve this crisis. Don't get me wrong, platform tooling is great. It provides visibility, tags your usage down to the experiment level, and sends budget alerts. But a tool can only tell you that a training run cost $40,000. It cannot tell you that the exact same result was achievable for a fraction of that cost. That requires custom engineering. True FinOps for AI is fundamentally an engineering discipline. It solves architecture, it dictates choosing a smaller, way more efficient model size. It manages data pipelines smartly and optimizes your GPU allocation across cloud providers. If you treat FinOps just as a tooling purchase, your savings are going to plateau fast. You have to treat cost as a core design constraint from day one.
Which leaves us with this final, really critical question. Is your next AI model an engineering design decision, or is it just an afterthought for the finance team? Because if you're bolting cost accountability on only after the invoices start climbing, you've already lost. But if you build it into the architecture itself, treating every endpoint as a calculated design choice with a real cost consequence, you will master your AI workloads. So take a hard look at your internal processes today and start designing for the future. Thank you so much for joining me for this explainer, and